All right, here we go. Let's do the review sheet. We are going to start off by graphing. So graphing means I need to get into slope-intercept form. So let's just do this one real quick. Let's go subtract 4x from both sides. I'm going to try to just do this right underneath it. Subtract 4x from both sides. Then I'm going to push it out to the side. Okay. So that would be y equals negative 4x plus 2. So there's one of my equations right there. This one, let's go ahead and subtract x from both sides. So that's going to give me negative y equals negative x plus 3. Can't leave the negative on there, so let's go ahead and divide by negative 1, divide by negative 1, divide by negative 1, and we get y is equal to positive x minus 3. And that will be my second one there. Okay, we got them in the slope-intercept form. Let us graph. So let's do the first one in blue, just so you see it. Go up 2, put a point, and then it says down negative 4. So again, if I wanted to, I'm going to go negative 4 over 1, right? So 1, 2, 3, 4 over 1. Bam, 1, 2, 3, 4 over 1. There's another, right? So then as we're thinking about graphing, whoa, man, that's not straight at all, is it? But that's okay. That's kind of the basic idea. Let me try to straighten it out a little bit. Okay, it looks like that. Let's go number 2 graph. Number 2, x equals negative 3, positive 1. All right, so we're going to go 1, 2, 3. Let's put a negative 3, positive 1, up 1, over 1. Boom, up 1, over 1. Boom. Looks like that. Let's see if we can't try to draw a straighter line than we did last time. Okay, but this is really all that matters, is that point that got overlapped. If I were to call that by name as an ordered pair, it looks like my x value is 1, my y value is negative 2. Now, I could check that and see if it works, but we also, the great thing about this review is we get to check it by doing substitution. All right, let's do substitution on this. Here's what I would do now. There's many different availabilities to you. I'm going to go ahead and just focus on this positive y right here. Okay, so let's rewrite this. Y equals negative 4x, because I subtracted 4x from this side, subtracted 4x from this side, plus 2. Okay, got it into a substitutable form, right? So which means you have to get one of the variables by itself. I'm going to take what y equals, and I'm going to literally plug it in right here. Okay, so then we get x minus, and here's the substitution, please, negative 4x plus 2 equals 3. Okay, now this is going to require us to take a negative across a parentheses to change some values. X plus 4x minus 2 equals 3. Okay, let's do a little bit of condensing on one side. 5x minus 2 equals 3. Next mode will be add 2 to both sides. So then we get 5x equals 5. And let's go ahead and divide by 5 on both sides. So then we get x is equal to 1. Okay, there we go. There's part of it right there. And then let's take this. Remember, here's where I like to plug it in. I like to take this and plug it right into this. That's why I boxed that in, just so I see it highlights. And then now we can go y equals negative 4. Instead of an x, we're going to put what x equals 1 plus 2. So then we're going to get y equals negative 4 plus 2, because that's 4 times, negative 4 times 1 is negative 4. Y equals negative 2. Then we're going to write that as an ordered pair, 1 comma negative 2. And we're going to hope it matches with this. It does. What do you know? Okay, what do you know? It should match that way. We're doing these correctly. Substitution. All right, let's go to elimination. Let's do the same thing. All right, I need to eliminate either the x's or the y's. The great thing about this one is, let's focus on the y's. Just take a look at the y's real quick. Just take a look at those. If I were to add the top equation to the bottom equation, it would just disappear already. So let's do that. 5x, that's 4x plus x, positive y plus a negative y is 0 equals 5, right? So it goes away automatically. Let's condense that down a little, equals 5. If I were to divide both sides by 5, then I would get x is equal to 1. Again, there's half your answer. Now go back up and pick either one. I just like this one. It just looks smaller. It looks easier to do. So let's plug in 1 minus y equals 3. Okay, let's subtract 1 from both sides. That way we get negative y equals 2. And then we got to get that negative off there, divide by negative 1 on both sides. So you get y is equal to negative 1. Oh, negative 2. That's 2 divided by negative 1, negative 2. So then my answer is 1 comma negative 2. How do we do? Yep. Perfect. All the same. There it is right there. And so that is the same thing. It's just going to drive this thing over and over and over again. All right, so let's do it again. Graphing. Here we go. So I need to get this in order. So the first thing I'm going to do is add 7x to both sides. So it's going to give me 2y equals positive 7x plus 18. All right, then let's divide by 2, divide by 2, divide by 2. So then we're going to get y equals 7 halves. I'm going to leave that as a fraction. That's going to be good for me. Plus 9. All right, oh man, that is supposed to be a 2 right there. It just didn't come out very well. 7 halves x over 9. Okay, let's do this one right here. The next one, subtract 6x from both sides. So you get 6y is equal to negative 6x plus 0. If you want to keep that 0 there, fine. Divided by 6, divided by 6. So then I get y is equal to negative x. Yeah, let's keep the plus 0, just for kicks and giggles. Okay, so let's go ahead and graph one of these in blue. So let's go to this one. So if I go blue, it's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's way up there. Now the slope says 7, 2. Remember, I can go up 7 and over 2. Or I can also go down 7 and backwards 2. That's going to keep it positive by going negative, negative. So go down 1, 2, 3, 4, 5, 6, 7. 1, 2. Put a point. So I got the big point there, the big point there, and I can do it again. 1, 2, 3, 4, 5, 6, 7 over 2. Right, so that looks like that. The only reason I would like to do that is just give me a little more space to draw that out. Okay, let's try this one here. I left the 0 on there on purpose, just so that like if you don't see the 0, know that there's a 0 there if you don't see any number hanging out there. But it makes me know that my y-intercept is 0, and I'm literally going to start at 0. And the slope is negative 1, so that means down 1 over 1. Down 1 over 1. Down 1 over 1. Right, and you could go backwards the other way, because actually going the other way would help tremendously, but check that out. They cross very nicely right there. So all we need to do is figure out that point. Looks like negative 2, positive 2, right? The x value is negative 2, the y value is positive 2, and we'd be done. All right, there we go. There is the graphing. Let's get right into the substitution. Well, so now this one, I got to pick one of these right here. I got to pick x or y or x or y. Here's what I'm seeing right now, just so that maybe you're seeing the same thing, is these both have 6's and then there's a 0. So when I go through and I have to do a division at the end, it's going to divide out nice and cleanly. So I'm going to focus on that x. For whatever reason, that's the one I want. Okay, so let's subtract 6y from both sides. So now I get the value of 6x is equal to negative 6y. Oh, there should be a y on there. Okay, so then now watch, when I divide by 6 on both sides, I get x is equal to negative y, or negative y plus 0 if you want, but hey, there it is. X is equal to negative y. That's all you're trying to do, get one variable by itself. Now you got to go take the other equation that you haven't plugged into, and you got to plug it into that. So this is going to go all the way here. It's going to snake around and go into that equation. So let's try it. Negative 7. Instead of x, we're going to replace with what x equals right now, which is negative y, plus 2y equals 18. Now let's work this part out right here. Negative 7 times negative y, the negative negative is a positive. So we're going to get positive 7y plus 2y equals 18. 7y plus 2y is 9y equals 18. Okay, and then of course we just got to get y by itself, so we're going to divide both sides by 9, and we get y is equal to 2. Oh, there is half my answer. Now we get to take it and let's just plop it right back in there. So x is equal to negative, instead of a y, we're going to put what y equals. So x is equal to negative 2. So it looks like we get negative 2, 2 as our answer for substitution, which, reminder, that's what we got for graphing. Perfect. All right, elimination. Elimination. So we take the top, add it to the bottom, and we want something to disappear. So I could try to get rid of the x's, or I could try to get rid of the y's. Now the x's, I don't like the 7 and the 6. That means I'm going to have to multiply both the top equation by something and the bottom equation by something in order to eliminate x's. But if I look at the y's, 6 and 2, I can actually just manipulate the top equation. If I multiply this by negative 3, I'd get a negative 6, which then would be opposite of the positive 6. But you can't just multiply that by negative 3. You got to multiply everything by negative 3. So that's why we say multiply by negative 3 and distribute. Okay, so let's plop that down here. So multiply the negative 7x times negative 3. That is 21x. Positive 2y times a negative 3 is a negative 6y. That's what we wanted. And 18 times a negative 3, that's going to be a little bit bigger number, but times negative 3, that is negative 54. Okay? Add together. Let's do this. 6x plus 21x, 27x. 6x plus a negative, 6y plus a negative 6y. Went away. That's the elimination there. 0 plus negative 54. Negative 54. That's it right there, right? So there you go. Condense it down, simplify it a little bit. Okay, looks like that. Let's get rid of the 27 here. Let's get rid of the 27 here. And we get x is equal to negative 2. There's half my answer. What do? Plug it in. You get to, again, you get to pick any two. I'd usually use the original ones because the original ones are usually a little bit smaller than the modified ones. So let's go back into this. 6, instead of an x, we're going to put negative 2 plus 6y is equal to 0. That's going to be negative 12 plus 6y is equal to 0. Let's add 12 to both sides. So then you're going to get 6y is equal to 12. Let's divide by 6 on both sides. And so we're going to get y is equal to 2. Boom. There's our answer. Again, negative 2, 2. Right? So there you go. Elimination process. Just rocking and rolling through this thing. Okay, here we go. Let's do one more of these. It looks like we do one more, and then we got some multiple choice to work through. And multiple choice is nice because it just flows a little nicer. Okay, so let's do this real quick. Let's subtract 2x from both sides. So y equals negative 2x plus 2. We are ready to graph this one here. Let's subtract 4x from both sides. So you get 2y equals negative 4x because it's subtracted from both sides, minus 4. Then I'm going to divide by 2, divide by 2, divide by 2. So then I'm going to get y equals negative 2x minus 2. Okay. So yeah, that's what we get. Okay, so let's do this real quick. Oh no, that's not what I wanted. Let's go blue on this one. So going blue, we got go to the 2 intercept, negative 2, down 1, 2 over 1. 1, 2 over 1. Perfect. That gets us something we can use. Okay, looks good. Let's go here. Let's try this one. Go negative 2 as my y-intercept, negative 2. And it says we're going to go down 2 over 1. Down 2 over 1. Okay, we're going to do that one. Okay, what do we have here? We have parallel lines. Parallel lines means they never intersect. If they never intersect, then we say no solution because we're always looking for the intersection of the two. All right, so we should end up with a no solution here too. Substitute. I can see right now that looks like my target, so let's get it there. So if I did 2x plus y equals 2, subtract 2x from both sides. I get y is equal to 2 minus 2x. All right, now we're ready to substitute. Substitute this into the other equation that we haven't used yet, which is this one right here, right there. We want to substitute it in. So let's go with that. Let's go 4x plus 2 times 2 minus 2x equals negative 4. All right. There's going to have to be a distribution here. So that we're going to get 4x plus 4 minus 4x equals negative 4. That's a lot of 4's in here. Okay, so let's clean up this side because we got a 4x and a negative 4x. We can combine like terms. When you combine them, you get 0. Still got the positive 4 equals negative 4. So clean that up. Positive 4 equals negative 4. Stop. X and y went away. Is this true or false? It is false. Therefore, no solution. If it's false, there's not a solution. If it was true, there would be infinite solutions or all real numbers. No solutions, that's what it looks like right there to do substitution. And then let's do elimination with that one right there. Okay, elimination, here we go. So I need the x's to cancel or the y's to cancel. It doesn't matter which one you focus on one of them. I'm just going to think about the x's. If I multiplied this by a negative 2, it would be opposite. But this needs to be by negative 2, and this needs to be by negative 2. So they all need to be by negative 2. So let's do it. So I'm going to rewrite it. Negative 4x minus 2y is equal to negative 4. Okay? So now I am going to focus only on my new modified equation and the one that was on the bottom, which is now on the top. Okay? So let's do this. 4x plus negative 4x, elimination. That's what we were trying to do. Positive 2y plus a negative 2y, that's also eliminated. Negative 4 plus negative 4 is negative 8. Simplify, 0 is equal to negative 8. Is this true? No, it's false. If it's false, guess what? No solution. There we go. All right, elimination method. All right, what is the solution to the graph, the systems graphed? Well, if we look at these two systems, looks like they graphed them for us. So all we got to do is find the point where they intersect. It looks like negative 1, positive 2. Negative 1, positive 2. Bam, there's our answer. Done. Okay, what's the solution to the equation? Now this, it does not tell you that you have to use graphing or you have to use substitution or elimination. You choose which one you want to use if you want to use that. The other way, guess what? This is multiple choice. I could plug that in, right? So let me try that, right? So negative 3 is the y value equals 2 times negative 2 is the x value minus 1. So negative 3 equals negative 4 minus 1. Negative 3 equals negative 5. Already, that is not true. That does not work, right? So let's try the next one, right? Let's try B. So let's try that. Negative 3 for my x value and 2 for the y value. So we get 2 is equal to 2 times negative 3 minus 1. So 2 is equal to negative 6 minus 1. 2 is equal to negative 7. Nope, 2 is not equal to negative 7. That doesn't work. Okay. Well, let's try again. Let's try something different. Let's go here. Let's try C. 3 and 2. So again, 2 is the x or the y value. 2 times 3 minus 1, because the x value is that. 2 is equal to 6 minus 1. 2 is equal to 5. 2 is not equal to 5, so it's not that one. All right, let's try one more. Let's try, it must be this last one. Let me just give it a shot. So 3, so if I plugged in 3 for y, 2 times 2 minus 1, 3 is equal to 4 minus 1, 3 is equal to 3. Boom, works. But we also, it needs to work for this one, so let's try that. 3 is equal to negative 2 plus 5. 3 is equal to negative 2 plus 5. 3 is equal to 3. Yes, there's our answer right there. So there's one way to do it without having to do substitution, graphing, or elimination if you choose. All right, let's try this one. Which two equations are represented in the following graph? Well, let's see. It looks like I'm going to have a y-intercept of 2 and a slope of 1, 2, 3 over 1. So it looks like we're going to have one that's going to have a slope of 3 and a y-intercept of 2. Okay, so that's going to be one of them. Let me think about the other one right here. Looks like a y-intercept of 4 and a slope of up 1 over 1. So the slope is equal to 1. So let's see which ones match, right? So this one has a negative slope, so that one's out. This one, part D down here has a negative slope and a negative slope. It's out because I saw that my slopes are both positive, right? So now I'm looking for which one of these matches, and C looks like it's the one that gives me the right slope and y-intercept combo, and we are good to go there. Which system has exactly one solution? Okay, one solution. So we're trying to say that they're either not the same, they can't be parallel, and they can't be the same line right here. So that's going to make a little modification here. So I'm going to say that's y equals subtract 4x, negative 4x minus 2. There's what the actual equation of that top one. Check it. They got the same slope. That means they are going to be, and same slope, different y-intercept. So that means they're going to be parallel. So that means there's going to be no solution. So that's out. I'm going to move down to the bottom one here. Slope is 4, slope is negative 1/4. So those are actually going to cross each other. And they have the same y-intercept. So it looks like they're going to cross each other at the same y-intercept. So I like that one there. We could keep going here and see what we end up with, right? So what if I took this and multiplied by 3? So then I'm going to get 6x plus 3y equals 12. Ooh, a 6x, 6x, 3y, 3y. Guess what? If I try to do some kind of elimination on that, the x's and y's will go away. So that's either going to be parallel or the same line. And so that's not going to work. This one they tried to do, let's see what form we want to get it into. Let's do the first one. Negative y is equal to negative 3x plus 2. Y is equal to 3x minus 2. So again, modifying it. This other one here, I'm going to do it in blue, is going to be y minus 4 is equal to 3x minus 6, right? That's just distribute. Add 4 to both sides. Y is equal to 3x minus 2. 3x minus 2, 3x minus 2, yikes, those are the same line. That's going to be an infinite solutions. So it looks like our answer is going to be C. Because the slopes are different, they will have to cross each other sometime. Which system of lines are parallel? That means we need the same slope, but not the same y-intersection. Right, so let's go for that one. Let's go see, we got negative y is equal to negative 2x plus 3. So then we get y is equal to 2x minus 3. Okay, 2x minus 3. This one here, I'm going to get, let's start it off by subtracting x from both sides. 2y is equal to negative x plus 3 divided by 2. Y is equal to negative 1/2 x plus 3/2. Slopes are not the same there, therefore can't be parallel. All right, let's try this one right here. Negative y is equal to negative x plus 10 because I subtracted x from both sides. Y is equal to positive x minus 10. Okay, there's that one. Right here, subtract x, y is equal to negative x plus 10. All right, that's just subtracting x from both sides. Slopes are not the same, not parallel. All right, so let's try this one. So subtract 2x, so we got 3y is equal to negative 2x plus 5, divided by 3y is equal to negative 2/3 x plus 5/3. Okay, there's that one. So I'm looking for another negative 2/3 x. Let's subtract 6x from both sides. So 9y is equal to negative 6x plus 1. Y is equal to, divide by 9 all the way across here. 6/9 is the same thing as negative 2/3 x plus 1/9. All right, I'm going to stop right there. Y-intercepts are definitely different, but the slopes are definitely the same. That's our answer right there, part B. All right, Julie is asked to solve the system by elimination. Elimination. Which of the following steps would be the best way to begin? Begin, right? So multiply the first one by 2 and multiply the second one by 3. So if I multiply the first one by 2 and the second one by 3, it looks like what they would be trying to do is make the x's opposites of each other. The problem is you need to multiply one of those by a negative value. So that's not going to help. Multiply, all right, so let me erase that. Let's try, I'm going to do the next one in blue. Multiply number 2 by 2. If I multiply this by 2, it's going to make that 6x, that negative 4. Well, that doesn't help me eliminate anything on the top, so I don't like that one. Let's try C. Multiply the number 1 by 2. Multiply the number 1 by 2, that's going to give me 4x, and that's going to be 2y. 2y and negative 2y? That would eliminate. Those would be opposites of each other. And then you could do multiply this one doesn't make sense either. So the answer there is C. That's their best bet. That's going to start the elimination process. Okay. For which system is negative 3, 5 the solution? We can go through and try to figure that one out by plugging in the values to figure out which one works. So let me give it a shot. So let's try 2 times negative 3 plus 5 equals negative 1. Negative 6 plus 5 equals negative 1. So it works for this one. So then you got to try that one down there. So let's try negative 3 plus 2y. Darn it. That's not what I want to do. That's not it. Okay, let's try that again. Plus 2 instead. Let's just start over again. Here we go. All right, here we go. X, the x value is negative 3 plus 2 times the y value, which is 5, and see if that's equal to 7. Negative 3 plus 10 is equal to 7. Ooh, 7 is equal to 7. That works as well. That's it right there. Wow, lucky shot right there. We got it right away. Now, if we tried it in these other ones, we're going to find out that one of those would have to be wrong. So that's it. All right, lastly, which graph represents the solution to the linear equations? All right, well, let's find out. One of them has got to have a negative 5. So that's got a negative 5. So that's in the running. This is a negative 5. It's in the running. This one does not have a negative 5 y-intercept. This one does. So I'm going to take C out right now by just doing that. Okay, with that negative 5, it's got to have a negative 3 slope. So negative 3 is down 1, 2, 3 over 1. So that looks like this could still be in the running. Down 1, 2, 3 over 1. Ooh, A is out. Now B, let's try it. D, 1, 2, 3 over 1. D is still in the running. Okay, so that works for that one. All right, let's look. We got to find one at a positive 1. A positive 1? Oh no, that one does not have a positive 1. This one does. Looks like D is going to be our answer. All right, there you go. There are the entire worksheet right there worked out for you. Check your answers, see how you're doing. We will see you tomorrow.